About the derivatives of natural log x and e to the x. So this first graph, this is a Desmos applet, and in red I've got the natural log function graphed. In green and the dashed line, that is our tangent line, and this blue dot represents the numerical value of the slope along this line. So let me see if I can get this to work for us. So before I just tell you what the derivative is, let's play it for you. All right, so remember that this green dot is tracing the slope and the blue dot's the numerical value. So we can see way over here, very steep, and then it flattens out. Now let's go ahead and take a look at the derivative. And there it is. So that is the, I guess, positive branch of our reciprocal function or rational function. Now, why don't we have a negative branch? Well, you can't take the natural log of a negative, so it's just going to be this positive branch in quadrant 1. So the derivative of our natural log function is the reciprocal function, the rational function, 1 over u times du dx. This, of course, represents the chain. Whatever that inside function is, u, times the derivative of u. 1 over u times the derivative of u with respect to x. All right, now let's take a look at our e to the x function. And once again, let's see if I can get this to work. All right, so let's push play. This in red is our e to the x function. The tangent line is the dashed, and the green dot represents the slope, or a point on that curve, I should say. All right, so now let's see if we can graph the derivative. Well, the derivative of e to the x is exactly itself, e to the x. Of course, don't forget the chain. So the derivative of e to the u is equal to e to the u times du dx. So those aren't too bad. Let's take a look at some examples. In this first example, I'm using our natural log, and so I went ahead and wrote the derivative right over here to the side. The derivative of our natural log, u, is 1 over u times the derivative of the inside function, du dx. Okay, so let's get started. 6 is just a coefficient, so I'll just write that out front. This 2x squared plus 3x represents our u. Du dx is the derivative of that, and so that would just be 4x plus 3. So if I'm using my my formula for the natural log of u, it's 1 over the u times the derivative of u. So I'm going to write times 1 over the u times the derivative of u. Now I can go ahead and combine those in the numerator, and I'd be perfectly happy with this answer. If you want to distribute, that's fine. Our next example, we've got e to the x. And just a reminder, the derivative of e to the u is equal to e to the u times the derivative of the chain, the inside function, du dx. What I also see is the quotient rule. And so it's bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. Okay, so let's keep that in mind as we find the derivative of this function. Okay, so let's see, bottom times derivative of the top. The derivative of the top would be e to the 2x times the inside function minus e to the x squared times the inside function. So I've got bottom times derivative of the top minus the top. And I'm going to go ahead and bracket that because I'm going to subtract this whole thing times derivative of the bottom. And I'm going to actually put some extra parentheses, and the derivative of the bottom would just be 3. Okay, so let me just make sure I've got this right. This is bottom times derivative of the top, derivative of u du dx. This is the inside function, minus e to the u times du dx. So bottom times derivative of the top minus the top times derivative of the bottom. And that's all going to be over the bottom squared. So 3x quantity squared would give me 9x squared. All right, so I could leave it like this, be perfectly happy, or maybe you recognize that in each of the first or second expressions, I can factor out a 3. I can cross this guy from this first factor or term and a 3 in this second term, and then cancel a 3 here. So really my only move here is maybe x times e to the 2x times 2, and maybe move that 2 in front, minus 2x e to the x squared, just to clean this up a bit. And then minus e to the 2x plus e to the x squared if I distribute the negative right in here. And then all divided by, how about 3x squared? And I think that one is fine just like that. I guess I could go ahead and distribute this x to both terms and maybe clear out one more set of parentheses, but I'm going to leave it just like that. All right, our next example, we have another e, an exponential function, but I also see a product rule right here. I've got two factors, this guy times this guy. So let's just make sure I remember the product rule. First times derivative of the second plus the second times derivative of the first. All right, and so let's see, first times derivative of the second, derivative of sine is cosine, inside function times the chain. So I have first times derivative of the second plus the second times derivative of the first. Derivative of e to the 4x is e to the 4x times the chain. Maybe you want to move this 2 up front, I guess. Right here, move him up front. Usually your numbers are in front, but it makes no difference to me. There's not a whole lot to simplify there. Okay, our next example, we've got the e to the x again. So the derivative of e to the x cubed plus 2x is e to the x cubed plus 2x times derivative of the inside function, 3x squared plus 2. And just leave it like this. Make sure your parentheses are around that whole inside function, so you know you're not just multiplying the e to the x cubed plus 2x times 3x squared. You're multiplying by the whole, this whole thing over here. Okay, a couple more examples. Yikes, when I see these square roots, I want to definitely rewrite this with rational exponents. So I've got x to the 1/2, e to the 1/2, e to the x to the 1/2, excuse me. Okay, so let's find the derivative. Oh, and what else do we see? Hopefully you recognize we've got the product rule. We've got this guy times this guy. All right, and so our product rule is first times derivative of the second, which is e to the x to the 1/2 times the chain. So the chain would be 1/2 x to the negative 1/2. Remember, you bring the exponent in front and you subtract 1 from the exponent. So 1/2 minus 2/2 gives you negative 1/2. All right, so we have first times derivative of the second plus the second times derivative of the first. Okay, so let's see what we can do to clean up here. Really, the only thing that I might recommend is when you've got these factors with these negative exponents, move them to the denominator. So maybe, and if you want, you can go ahead and rewrite the rational exponents with the square roots. It doesn't really matter to me. Let's just think about this. We've got square root of x times e to the square root of x, all divided by 2 square root of x plus e to the square root of x divided by 2, and looks like we have a square root of x if I were to move them to the denominator. And I think that's probably it. Oh, how about this guy? Let's cancel that. Now I think that's about it. Okay, one last example. Wow, a lot going on here. We got the quotient rule, we got natural log, and we got e to the x. So I didn't write my quotient rule. Bottom times root of the top minus top times root of the bottom over bottom squared. Okay, we have a lot going on here. Okay, let's do it. Bottom times derivative of the top. Okay, this is our u. So that's going to be 1 over the u value times derivative of u. So 2x, that's it. So I have bottom times derivative of the top minus the top times derivative of the bottom. Looks like in the bottom we have just a bunch of chain rule, or a power rule with the chain rule. So let me clear that out. So bottom derivative of the top minus the top times derivative of the bottom. So that's going to be e to the x, and the derivative of x is just 1. So I'm just not even going to leave that there. Plus, okay, bottom derivative of the top minus top derivative of the bottom. So that's 2. And derivative of 1 is just 0. All divided by the bottom squared. Not a whole lot. You want to simplify. Ooh, I do want to go ahead and bracket this because remember we're subtracting the whole thing. Oop, almost missed that. So I don't want to miss that. And maybe I put parentheses around that if I want to get it right. And I think I do. So I'm just double checking my work. Bottom derivative of the top with the chain minus, and we're minusing the whole thing, the top times derivative of the bottom, e to the x. The chain rule will give you a 1 plus 2, bottom squared. Yep, I'm happy with that.